Now, when we talk about PET scan, right, the PET scan is basically the same, what do you call it, same shape, right, as CT scan, in the sense that they have all these rings. This one ring here, then you lie down here, then you go in. So many people confuse the PET scan with the CT scan, but actually the technology behind this PET scan is completely different. And usually PET scan, right, you can use it to like scan which part of your body is actively consuming glucose. Because what happens is they will inject, right, a tracer into your body. So the tracer, right, will contain a substance, right, that is radioactive. So usually the fluorine 18 is attached to the, what do you call it, the to that particular tracer called the fluorodeoxyglucose. All right, and the fluorine 18 inside here will actually decay and emit a beta plus particle or a positron. Okay, so the positron will actually be emitted by your fluorine 18, and what will happen is because it is near your body atoms, right? So your atoms will also have electron orbiting it, right? So therefore, when the positron collides with the electron in the tissue, they will actually annihilate each other. So why they annihilate each other? Because the rule is, if a matter, which is your electron, collides with the corresponding antimatter, which is a positron, they will annihilate each other and form two gamma photons. But because they're going to consider, right, that both these Ke are initially negligible. Not to say they're not moving, because this is moving very slowly. This is orbiting relatively slow. Now, slow to what? The speed of the two photons being emitted. So they will consider that these two, right, have the momentum to be zero, assumption. So therefore, if your total initial momentum is zero, your total final momentum will also be zero. So they will assume, right, that they'll move opposite directions, which will obey conservation of momentum. So what will happen is, when the ring, right, is around your body, the two gamma photons will be emitted in opposite directions, and they will hit the detector on the opposite sides. And the difference in the time where it hits the detector will tell the computer where it came from, whether it's nearer to the left or in the center or in the right. Because in the center, they will reach at the same time. If on the left, this side will reach first, this side will reach later. If on the right, this side will reach first, this side will reach later. Right? So from the time taken, they can actually predict where that particular gamma photons are emitted. Now, why do they want to do this? I'll give you an example. Let's say you want to scan, right, the tumor, how big the tumor is in a particular patient. So when you inject that tracer, right, which contains glucose, the cancer cells are more metabolically active. That means they will consume more glucose than the regular healthy cells. So what will happen is, the gamma photons emitted by your tumorous cells, right, will actually be much more. So it will light up. So that means on the screen, right, you will see that particular they will actually plot it as a very bright area. So that is the tumor. Whereas regular cells won't consume so much glucose. And we can also use PET scans, right, to like scan which part of your brain is active when you're doing different tasks. Like if you're doing a maths task, which part of your brain is using the glucose, then that shows that brain is active, that part of the brain is active. Or if you're doing art, or if you're stressed, or you're angry, what kind of which part of your brain actually is being used. So that is the use of this particular PET scan. Okay, now the equation we use, right, for PET scan is actually quite simple, because each gamma photon is actually a photon. So remember your equation for what they call it, photon E equals to HF, or E equals to HC over lambda. All right, so we just have to use this but the question is, how do I use this E equals to HF or E equals to HC over lambda? You remember that you have two particles annihilating each other, right? You got electron and a positron, correct? So the electron and the positron both have the same mass, correct or not? So in other words, when you produce two gamma photons, can you then say that one of the electron produce one gamma and one positron produce another gamma? Can I not? So you remember also Einstein's formula that relates energy and mass, E equals to mc squared, right? Not? So we will take like the mass of one electron, because that disappears, that will become one photon. So mc squared, mass of the electron, times c squared will become the energy of this that the electron, the mass of the electron becomes, and that will become the energy of the photon. So E, so it means you can get the frequency of the gamma photon by using HF equals to mc squared. Okay, so that is quite straightforward lah. So remember, if you are calculating the energy of one photon, you just need one of the mass, either the electron or the positron. You don't add them because they're producing two gamma photons. So one gamma comes from one of them only. Right, and there's this equation here which they want you to know as well. So if you want to derive this, what is this equation representing? This is momentum in terms of the energy of the photon. All right, this is the E, and the C is the speed of light. So this is the momentum photon. How we derive actually quite simple. We started from the Broy's equation. Remember, lambda equals h over p. That means if the you can actually get the momentum of the photon if you know the wavelength of the photon. So if, let's say you substitute your wavelength of the photon, of the gamma photon, so you get the momentum. But you also remember that the energy of photon is E equals to hc over lambda. So your h over lambda is p, right? So if you substitute your you rearrange this equation, you get h over lambda E over c. So h over lambda is p. So I just write one final equation here, one final one. So you substitute the h over lambda here as p. So then you get p equals to E over c. Alright, so that's actually they didn't ask you to derive, but if you wanted to know how you derive, this is how. But this equation is the one they want you to remember.